is called Change in Tandem. So it's going to be somewhat of a review of things that you've probably heard of before, but I'm going to put a little bit of a spin on it. There's not much computation today, but we are going to be reading a lot of graphs because being able to read and interpret a graph is going to be like major cornerstone of this class. So we'll just start at the beginning. A function, words we've heard before. A function is a mathematical relation that maps a set of input values to a set of output values such that each input value is mapped to exactly one output value. We've heard the definition of a function many times before. The definition has not changed. However, when you were in other classes, you probably used what was called the vertical line test to test if something is a function. That will work for a lot of what we'll do in this class, but sometimes it won't work because we're going to be learning about more complicated formulas where the vertical line test does not work. But for the most part and for right now, we can still use the vertical line test to determine if something is a function. More vocabulary we've heard before. The set of input values, that might be a highlighting moment, of a function is called the domain. It is represented by the independent variable. We didn't use x and y here because not all the time are we going to be having functions related to x and y. Sometimes we're going to be related to time, so it'll be t. So we just need to know not necessarily the x and the y values, but the independent, and then, of course, for the output values, that is the range, will be represented by the dependent variable. So typically that is x and y, but just depending on how your function is defined, that might change. All vocabulary we've used before. Understanding the domain and the range of a function, again, because this is so critical for understanding what the kinds of things I'm going to be asking for you to do in this class, we really need to nail that one down. Domain is the input values, range is the output values. But these functions just basically give us rules for how the two variables are related to each other. And depending on how they tell us the rule depends on what kind of graph we can create. So for example, in example 1, it says sketch a graph for just between -4 and 4. So we're not going off screen here. It's just saying from -4 to 4 on the x-axis, please do the following. And it says the function f halves each input value and then adds 1. So if I were to write this into an equation as a rule instead of words as a rule, I would say take half of the input value, 1/2 x, and then add 1. Now typically that's y equals, which creates a line, but that's all that the rule gave us, is that the function f of x, halves each input value and then adds 1. So if we were trying to graph that, we would need to know what happens at the endpoints. The endpoints are going to come from these two numbers that it just happened to give us arbitrarily. Meaning we would find what happens at 1/2 times -4 plus 1, which would be -1. Half of -4 is -2 plus 1 is -1. And we would like to figure out what's happening at 4, the other endpoint for the domain or the region that I care about. Half of 4 is 2 plus 1 is 3. So I have two coordinate points that I can plot. I have the coordinate point -4, -1. Input value was -4, output value was -1, and I have the other coordinate point of 4, 3. Now what's happening in between here is all of these dots, every input value in between would follow that line. Now we didn't draw arrows going off to the side of this one. It is a line segment because I only care about what's happening at -4 and 4, since that was what the question asked. If it didn't give you those boundaries, it would need to be a line with arrows, but it said only between those two things do we really care about. It's still just a function relating x's to y's or inputs to outputs as it always has been. For the second one, again, the information it gives us isn't a word blurb. This time it's this table, and it's just a table of values. And since we don't know if they're related by a discrete or continuous function, we are just going to plot all of these points, and it will answer the question. So we could plot -4, -1, -1, 2, good old-fashioned plotting points, 0, 3, 2, 3, and 4, 1. Good old-fashioned plotting points. We're not going to draw a line connecting these because we don't know if it's discrete or continuous, meaning discrete is dots, continuous is lines, curves. So we're just going to plot some points. It's a function. All of the x values map to exactly one output value. None of the x's repeat. It passes the vertical line test. All of the things we've said for forever, that still exist for functions. But the way we're going to practice today, mostly describing functions, reading graphs, and interpreting them, is with this little chart here, adding in 4 vocabulary words. They're not all that difficult, but they get confusing when we start putting them together. Doesn't sound like it because it's literally the words increasing and decreasing, but I promise you it's weird. When functions are increasing, as the input values increase, the output values increase. Makes sense, it's going uphill. That one's not difficult. Decreasing means, again, as the input values increase, the output values decrease. So it's going downhill. Words you may not have used before, though, are concave up and concave down. When we are talking about concave up, we're talking about the slopes changing at an increasing rate, which is a difficult concept at first to look at. So what we can think about is the fact that if it were a parabola, it would be opening up. That's a word you might have used before. Opens up, that means it's concave up. And of course, if we say concave down, we're talking about the rate of change decreasing as we go across this graph. So in other words, it's opening down. And that's all fine and dandy. We can really see things that are increasing and decreasing pretty easy. And with parabolas, we can see concavity pretty easily. Concave up means opening up. Concave down means opening down. But it's not always going to be that simple because sometimes the graphs are going to be more complicated than cute little linear and cute little parabolas. For example, look on the back of your notes. On the back of your notes, we have this function here. It's called a piecewise function. You don't need to know that, but it's basically multiple types of functions all Frankensteined together on one graph. We're allowed to do this. We're allowed to take multiple functions and piece them together so long as it passes the vertical line test, which this does. Meaning we can talk about the intervals from -4 to 7 on the x-axis for these different things. So let's talk about increasing. Where is this graph increasing is the first question. So we need to know where this graph is going uphill. I'm going to highlight a bunch on here. I would recommend, because I'm going to highlight multiple things, maybe color code it, maybe share some highlighters amongst you to do this. But we want to know where this graph is increasing, meaning we want to know when the graph is tilted upwards, going upwards, increasing. There are only 2 sections of this graph that are increasing. Those 2 sections are from here to here. Would you agree that the graph is going uphill? It's not in a straight line, but that curve is going uphill. And then additionally from here to here, that graph is going uphill. It's increasing. If you were to be walking along this graph, you would be walking uphill. It's a curved uphill, but it's uphill nonetheless. So to answer part A that asks you, when is the graph of h increasing, or the function h increasing, you would say from -2 to 0. That's the first little green section I highlighted. Or the word and, I always say and, but technically that means or, from 4 to 7, because that's the other section that I highlighted green. If we ask decreasing, obviously that's pretty much everything else. So we have this section that's going downhill, and we have this section that would also be downhill in a curved way. Still going down if I were to be walking across this graph. So the answer for where is h decreasing would be from -4 to -2, or from 0 to 4. Now I want to ask you a couple questions here because they made me pause when I was doing this problem. How come I didn't put infinities in my intervals? There's no arrows. We have actual endpoints here. This graph is only defined, that's the word you're going to be hearing, only defined from -4 to 7. It doesn't keep going after that. We have no information beyond those little endpoints. So we're going to pretend like it stops at that endpoint. In fact, it does. It's not pretending. It stops at the endpoint for what we care about. Okay, second question I asked myself when I was going over this again, why no brackets? And that's a big question. Why no brackets? In my interval answers, why are they all parentheses? So it's a great question. It's kind of difficult. We're switching off increasing or decreasing at the coordinate point -2. What's happening at -2? It changes directions, right? So exactly at -2, it is not increasing or decreasing, it's changing direction. If I were to try to put a line like tangent to it, I'd have no idea how to go tangent because it's essentially like a point. Instead of 2 points, it's like 1. So we have no idea what really happens at those endpoints. So that's why specifically in this question, it says the open intervals, because there's some disagreement in the math community about whether it should be open parentheses or closed parentheses. So if they say open intervals, which it will, this class will say open intervals, we're going to use parentheses for all of these. You may not even have had that question, but that is a good question to have. Okay, the next question is, where is H concave up? Concave up on the other side of this paper was the parabola that opened up. Now, none of this is exactly a parabola, but is there a section that is opening upwards? Yeah, if we see that there is this section right here, and I'm going to double highlight, which I know is hard for you to not double highlight. This section here, if it were an actual parabola, its endpoints would be opening upwards. So that is where this graph is concave up. From from 2 to 7. Concave up. Now, it doesn't ask this, but I think it'd be important for highlighting purposes. Where is it concave down? Just plain concave down. From -2 to 2. Wow, this is the worst highlighting job I've ever done. Straight lines do not have any concavity to them, so I'm not going to double highlight the section from -4 to -2, that little straight line. It's not concave at all. There's no concavity there. But we have these sections that are different concavities, one of them opening up, one of them opening down. But we can get even more specific with the question. We can combine these two things together. So the next one says, which section is both increasing and concave down? There's only one little section where it is both increasing, I highlighted in green, and concave down, I highlighted in purple. Yeah, from -2 to 0. That's the only little section that was both increasing, green in my color code, and concave down, purple in my color code. So the next question that says H is both decreasing and concave up. Decreasing for me was red color and concave up was blue. So what interval is that? 2 to 4. Now this is way easier when it's all this highlighted, which you can totally do. But here's another way that we can do this. Hopefully, okay, now that we have the little hand trick, we can keep going. Now these questions get more difficult very quickly because I want to be able to use a description of a graph to sketch what it could possibly look like with all of these different descriptions. It says the graph of K is increasing on the intervals from -4 to 1 and from 5 to 7. Decreasing on the interval from 1 to 5, and the graph of K is concave up on the interval from 3 to 6 and concave down on those two intervals, and we're going to sketch that graph. That's a lot of things happening in very little time. Here's how I would attack this problem. I'm going to take every change coordinate point, it's going to be called a point of inflection later, every point of inflection, and kind of like put it as a critical number on my number line, meaning if we know it's increasing on the interval from -4 to 1, that means at 1, not -1, at 1, something happens. And in fact, it changes from increasing to decreasing. And it's decreasing until we get to 5. Where am I getting these numbers from? Great question. Right here. That is where it's going to change from increasing to decreasing and then decreasing to increasing again. Now, additionally, we have concavity changes. The graph of K is concave up on the interval from 3 to 6, so I'm going to go ahead and put 2 more coordinate points on 3 and 6. I'm using a slightly different color just to help me out. And concave down on the intervals from -4 to 3 and from 6 to 7. So at all of these coordinate points, something new in my graph is going to happen, and we have to change it when we're sketching it. We've plotted all of our important points, and because I think it would be helpful, let's color code a little bit. So we know that from increasing intervals will be from -4 to 1, and then from 5 to 7. That's the section of my graph that should be increasing, which means in between that should be decreasing. I also know that for concavity, it is concave down from -4 to 3 and from 6 to 7, and it'll be concave up in between those 2 points. We've got a lot of things happening with this graph that we are just sketching. Remember, sketch just means like literally sketch it. You don't have to plot points, you just have to get it to act right. So in this first section, we need from the first critical point to the next critical point, our points of inflection, what should our graph look like? Show me with your hands. We've colored it as the positive color and as concave down color. So what does that look like with your hands? Concave down, and which side is positive? Okay, that's what we need our graph to look like. So we would sketch something that looks, I don't know, like this. Does that match what your hand looked like? Okay, great, sketch that. The next color coding I have there is red, which means decreasing, but also concave down. So what does that look like with your hand when it's concave down but decreasing? This hand, yeah, your right hand. So we have this other little section that kind of does this. And then something's going to happen at 3. We switch and we have decreasing but concave up. So with your hands, what does concave up look like? And which side is decreasing? This one, that's what your graph should kind of look like. Is that what hand you held up? Now for one little bit, we switch to increasing and opens up, concave up, which means looks like this. And then we switch to increasing, concave down. Oh boy. It's a lot, but if you get it to match the shapes of your hands for all of these, it will be a little bit more visual and helpful. So if we walk through that one more time. This section we said is positive and concave down. Concave down is the sad parabola. Positive was your left hand. That matches your left hand. Then it switches to decreasing, still concave down, which is the right hand. Switches to concave up. Switches, and then switches. So the hands are going to help you remember what shape the graph should sort of take when you're sketching them. That's a lot. So let's put it in that color code one more time. This is a sine function. When we get into our trig unit, which is our 3rd unit in this class, I'll actually explain more about this. However, what we're going to do is talk about concavity and increasing, decreasing here. So first, whatever color you've used or however you've showed that it was increasing, which section of this graph is increasing? Hopefully you're like the middle part. Yeah, the middle part is going uphill in a curved way. And these 2 end sections are the ones decreasing. So let's label that. So this is a decreasing, this is decreasing, and these 2 sections are increasing. Increasing, decreasing, do we feel okay? Okay. Concavity has to do with the parabolas, if they were just parabolas, what matches your hand shape, what bowls or cups it creates. So for concave up, it's the part that would be opening up. That's this section here. So this is concave up. Are y'all okay with me shortening it to that? And this is concave up. That matches the parabola you can make with your hands. This section here, this interval here, is concave down. So this is what concave down increasing looks like, and concave down decreasing looks like. Those are going to be the 4 combinations of this change in tandem vocabulary, increasing, decreasing, and concavities that we are going to use. How are we doing? Good? Okay? I'll give you a couple seconds to get all the highlight. I know you might be sharing highlighters to get it all put together, and then we're going to be done with notes and move on to thinking exercises, which means we get to think a little bit. Yay!